Session. I hope you ate well. How's your con going so far? Good? Glad to hear it. This was one of my favorite cons. I'd like to introduce to you today Allison Miller. Whoops, where is she? Over there. She's known as Selena Kyle on Twitter, and she does security analytics and economics of security. And this is Davi, who told me to tell you that he is the Senior Director of Trust. We're not sure how he defines trust. But today they're going to talk to us about data whales and troll tiers, which they have told me it means keep on doing what we're doing, but do it better. So.
All right. Thanks for coming today. After lunch is always a hard session, so hopefully we can keep you awake in this. First, I want to apologize to Allison for putting her into this mess and forcing her to be on screen, but I think it's going to be worthwhile. The presentation is really centered around trying to change how we do things and maybe talk about some controversial aspects of what people say. That's kind of where we came up with this, well, I shouldn't say I came up with it, but Allison came up with this title, Data Whales and Troll Tiers, during a discussion about some of the things going on in the industry. This is a more formal slide, I guess you could say. Anybody know the origins of the shmoo, the history of the shmoo? Anybody know the origin of the shmoo? No, I mean the actual character, the cap. Yeah. Yeah, well, he was in Lil Abner, but it's just interesting to me that the guy made so much money during the Depression. He was making hundreds of thousands of dollars while everybody else was making nothing. It's kind of an interesting phenomenon about how people get an idea about what they like and they pay for it even when there's no money around. But we're going to talk about two things today, really boil down the entire presentation. It's going to be about how the landscape has changed, which is sort of your average presentation about how things are getting harder and more difficult, but hopefully we'll find some elements of truth there that you can use to apply in defense of your environment. And then the second is the defense modes and the evolution of which we're saying there are generally two arguments to be made about what to do and which one's better, and we're going to try to propose a third, which isn't that unusual, but hopefully you'll see how it's a progression rather than a change from one to another. It's not a binary decision. So we'll start with Allison really giving the landscape section, then I'll jump in and do some of the defense modes and analysis, and then we'll sort of split up the end in the presentation. So with that, I'll hand it over to Allison to talk about how the landscape is changing.
Okay, so basically, I think that all of us know as we've been developing out the discipline of securing systems and securing data that at the same time, the reason why that has become more of a mandate is because so much more of the components that make our lives work and so much more of business is happening in computers, in networks, online, and not only is that infrastructure getting better or bigger and more important, compelling parts of our lives, but it is growing in complexity. There's a lot more heterogeneity in the networks and systems that we're building. So, which slide are we on, Davi? Can we be on the
rising scale and complexity of IT?
What?
The rising scale and complexity of IT. Okay,
let's move to the next one and talk a little bit about how this has been expanding out, where we came from and now where we are, which is in the beginning, if you will, we were working on centralized systems that we accessed, but the data was all in kind of a mother load sort of system with a lot of potential controls around how we accessed that and what data was going to be held there. Then there came the second wave with proliferation of individual devices such as PCs, moving to more of a client-server type architecture. And as that grew, this means that there are more people who are part of these ever-growing networks, more applications, more ways to access the data until we are where we are now, which is we're not just in networks, we are dealing with platforms, platforms on which additional applications may run, or those applications may be creating data, may be moving data, creating an exposure surface, but also bringing millions and billions of people to them, and potentially tracking or instrumenting all kinds of events and facts that are then getting housed and transferred back and forth in the form of services and in the form of data. So next slide. So really, the center of all this is the data, our preferences, activities, favorites, likes, winks. All of this becomes data, along with data that we think of as being important to our lives, our health data, our financial data, our bills and such. And that data is the lifeblood, essentially, that is powering a lot of these new platform-driven businesses. So data is really what is allowing new business models such as social, what's really driving mobile, and why cloud has become so important to us. Davi, did you want to say anything about cloud or mobile?
Well, sure. I mean, I usually use gravity in this slide. In fact, my next presentation at RSA conference will be about gravity. But for this presentation, whales fits quite well. As if you think about the whaling industry, it was like all these people trying to get the whales to use. And that's kind of the same situation we're in. So cloud only works if you have tons of data in it. Same with social and mobile. So it's sort of like these boats circling around the whale looking for ways to get access. And that creates an interesting threat model, of course, because you're trying to do good things, but at the same time, there's a lot of pressure for people to get in and do bad things. And so it's changing the way we defend our networks. And I'm actually working now on a lot of research around how to protect big data environments, because the way that we defend them is so different. Scale is changing everything. Protecting 1,000 systems is very different than trying to build 10,000 or even 100,000 systems and protect it. So whales, being as big as they are changing how we do defense. Here are some examples, if you want to continue.
Okay, so the next slide with the data whale examples.
Yep.
So there are a number of different businesses that are becoming data whales in and of their own right. One of the things Sandy mentioned in my introduction is that one of the things that I do is security or risk data analytics, and I've done that in a number of environments. And scale creates a lot of opportunities. It allows you to really identify some interesting patterns that might be hidden if you didn't have all of that data. So that is true in finance and banking and e-commerce, online, as well as industries that you might not think would need it, like gaming or gambling, rather. But then, of course, you then come to companies like travel and insurance that have always held a lot of data and used it in interesting ways. So one note about these example industries is that their business models really do depend on them having a certain scale. Once they get to a certain scale, it's easier for them to compete, which is why you often see consolidation across these folks. Next slide. And the reason why they really need that data is to give them because it allows them to create tailored services for their customers or to optimize their own profitability. Davi, do you want to explain what this example is?
Yeah, this is actually a real example from some data scientists that I stole from them because they didn't have very good security. And basically the idea is that they can find insights sometimes that, if they're trained, they can see things like this circle represents how you might have a huge distribution of data points, and they can find something that's different or unusual. So they can find fraud, for example, or they can find attacks, or they can essentially find things in the data that create intelligence. We're getting some noise from.
Hi. Crickets chirping?
Yeah, that's better. So as I was saying, there's a lot of data, and like wind noise. That's actually a pretty good analogy, because there's a lot of noise and you can find signal. But one of the strange, how many people here actually were affected by the Target breach? How many people received a letter or an email from Target? Quite a few. And how many people shopped in the past 12 months at Target that received a letter? Quite a few people. So yeah, it's an example. They're collecting huge amounts of data, and they're keeping it for a really long time, and that's sort of how they generate their power to build a relationship with you. And so there are people mining this all the time. That's sort of the bottom line. So next slide. From data comes risk, as I was just describing.
Right. So controlling access to this information is really what security is. And as this data comes from all of these different sources in these different forms, it has really expanded the attack surface and therefore our exposure surface. So in the past, you might have been able to count on the databases of a company being in one or two places, being fairly structured, being able to quickly identify which pieces of information or tables or systems were sensitive. But now information is basically like water, passes between these systems and can be in a very unstructured way from all kinds of devices and all kinds of formats. And that can be not just, say, your sensitive financial records or your employee records or patient records, but what it is that makes your company work. If you think about consumer-facing platforms like Facebook, every single thing a person does could be considered personal activity, and that is not just a database that sits somewhere. That is all of that platform. And then depending on how sophisticated the company is, they may have even pulled in information from third parties or data that can be correlated from other sources that when put together becomes something interesting that you'd want to protect, that you hadn't thought the individual pieces were that important. And the thing that is really an interesting problem for us as information security professionals is the fact that this data really is taking on a life of its own because their history is ever present. This information just continues to grow and grow to the tune of over 7,000 petabytes per day, potentially across all of these different sort of enterprises and systems. That is a lot of data, and it's not disappearing nicely. It doesn't just decompose organically. Next slide. So one of the things that I have to deal with in my job of risk analytics is that I am not always, in fact, I actually am not very focused on defending the heart of an enterprise. While my system includes all of these different types of places where data can live or information that is part of how my company works, I actually am sort of interested in the threat that actually comes from, that comes to bear on users. Because users, if you sort of think of all of these things as being connected, there's the boundaries between a platform and a platform's users are very permeable. So in a lot of cases we've always seen that attackers are going to go hit an endpoint. But now where is our endpoint? Our endpoint isn't necessarily a device within our control. It's a device within our customer's control. In so much as our customers have control of their tablets and desktops and PCs and phones and all of the individual data that they end up sharing with folks. So my work actually involves understanding threats that are targeting our customers. And so it's interesting how even though I work on a platform, the boundaries of my platform really don't end. I have to be looking constantly outward because those attacks may be coming in a different form, not against a defensible system, but against a connected customer. Next slide, and back to you, Davi.
All right, so this is a generic marketing slide, but you basically see the problem is that as things are changing, so too does security have to change. And back to my title, Director of Trust, Senior Director of Trust, I get asked all the time, what does that mean? And sometimes people just want it so they can use it. Apparently it works well in bars when you say, hey, I'm Senior Director of Trust. You can trust me. Exactly, trust me. But what does it really mean? I mean, the difference between trust and security in a nutshell is like, if you ask me why trust a cloud, it's basically because the data should be highly available. The data should be have high integrity, should be something you can back up quickly. If you're compromised and you can restore a clean system very quickly, right, you trust that system more because it's clean data. And you don't want available data that's bad spread around. So those are two key components. And then the third is the confidentiality, of course, protecting it from a breach. So trust has three main components. And if you think about the first two, it's like the more available data is, the more it's spread around. You're breaking down perimeters because you have it in two cities, for example. Or the more integrity you have, again, you're spreading it around and you're keeping it in big lakes because you want to be able to dip into them and pull back very quickly. So you get performance as a priority in integrity, so you can restore servers quickly. So you're getting rid of perimeters. This is like one of the big paradoxes of trust, because the third is confidentiality. You're actually building perimeters at the same time you're destroying them in order to achieve the other 2/3 of your objective, right? So our world is really changing, and how do you build trust around these giant environments that are so big, it's like impossible to build controls like we used to? I used to get asked questions like this at some jobs where they'd say, how would you architect a solution for defending this environment of 10 million users? And you'd think, well, I used to do this for 1,000 users, and that just won't work. It won't scale, it'll get in the way, and nobody can get access. I'll create a denial of service condition, so I have to re-architect around a whole new way of using the service, let alone how people are evolving to attack us. So let me talk for a second here. I'll go fairly fast through this, so you can ask me questions after. But let me talk about how not only are the attackers shifting and changing. Back to the Target breach, how many people read the news today about the complexity of the breach and what exactly happened? Anybody see the news today about, yeah, like default passwords, wide open networks, so some pretty crazy stuff. All right, so how sophisticated are attackers exactly? That's the point of this next section, and what have we learned about them in the past? So first of all, there's a lot of breach data available, and you can read through it if you want. I read through it all the time. I've done several presentations on this where I show the contradictions within the different reports. Here's just a simple list of some of the places I've looked. What I've started to notice recently is that we have better reporting out of the government, which is nice because it's a non-partial source. One of the issues is that a lot of the sources have a very particular view. They're only looking at their customers in their industries and generating a response from that we're supposed to believe is applicable across all of the different attacks that we see. So for example, there's a quick quiz in breach sources. How many people would vote with Verizon, or how many people would vote with Trustwave? So first, how many people believe Verizon that breach sources are 0% partners? None of the breaches come from partners. Anybody side with that? Okay. Now, how many people believe 76% of attacks come from partners, right? More? So, okay. So Trustwave wins on that one. So second, like spam sources. In one sense, Trend Micro says India and Russia are the biggest spam sources. And then Sophos, on the other hand, says the United States is the biggest spam source. So you can see there's a difference there. And then finally, you can ask yourself, do you agree with Sophos that Chile, China, and South Korea are the most attacked PCs in the world, or do you agree with Trustwave that the US, Australia, and Canada, all English-speaking countries, are the most attacked? So you can see if you read the breach reports, you're like, I don't get it. You contradict. There's different patterns here. Is it English-speaking countries only? Is it diverse countries? Where really should I be looking? And then it gets more complicated. Within the reports themselves, they contradict each other. So how many people would vote with Verizon versus vote with Verizon? That sophistication, first, is one of the main themes that stands out, versus Verizon that says actually 80% of the intrusions were rated as low or low difficulty. So, well, that's the idea, though, is that if you read the report, you see both come out. How do you know what the actual answer is? Like, what is the... That's actually the next, we're jumping ahead, that's the next slide. But if you wait a second, very good point. And in the second part, the Trustwave report says, again, the same thing, the ever-increasing level of sophistication on malware authors, and then 90% of attacks are coming through with blank or weak passwords. And so actually in the Target breach, we saw this. They're actually reporting now that it was very likely to be very weak passwords used by the malware authors in order to get access. So with that as a background. The good news is we actually are seeing that patch management is working, probably because the vast majority of these flaws that are being exploited are in the low end of the spectrum. So we're seeing positive results in patch management, which we shouldn't discount, right? We can automate and distribute our systems. We used to, so for example, in 140,000 systems that I worked on once, we were able to get to about 80%, which was pretty good. On smaller environments, we get to 90% or so. So patch management's actually kind of moving along. The problem is it really sucks in a lot of areas, like Java apparently is only 5% patched, the data I've been reading. And another scary one is I think 30% of the market is still Windows XP, and like 95% of ATMs are still Windows XP. And we're not doing a great job patching some of those environments. This graph, by the way, just sort of illustrates that in terms of patches going up, we're seeing more and more patches. The time to run the patches and the outages caused to the systems that are being patched has gone down dramatically. So the disincentive is actually going away. And I mention this because some very large cloud providers do not patch because they're worried about availability first and foremost. They will not patch a system and take the systems down because availability is what they're measured on by their customers. They're not really measured by their customers on whether the system's been compromised, only whether it's been down in availability. Scary. So you're out there watering the plants and the plants are growing is sort of the analogy I'm using here. And so another thing to think about is confidence that people have in their ability to use their environment with trust. So what we found at EMC, we did a survey around the world, just came out. And so in a global survey of leaders, we found that financial services believes their environment is trusted more than anyone. Life sciences is second. And I'll show you why these are colored in a second. It's because in confidence, suddenly life sciences drops to the bottom and consulting jumps up to the top. So consultants, you have the least trusted environments, meaning the least ability to recover quickly, the least ability to protect the confidentiality of data, right? The controls are not in place. They believe that they have one of the highest levels in the industry. And so that sort of goes to the question, if an environment was using a lot of consultants, is that a backdoor into that environment? We found that in several cases. For example, the F-35 strike fighter, the contractors, or the Snowden example, the contractors are getting access and taking data out of those environments. So patching is working, but the reality is it's working in an area that might not be the most effective. So this really cool study by Dan Geer and Michael Reutman shows that the 87% of CVS scores that are high that you're patching aren't actually being attacked. It's the 2.4% that are being attacked that you should be focusing on. And the way they looked at probabilities of attackers coming in is by looking at actually the tools that people are using to attack you. So it's a kind of a different metric, a different way of analyzing what you should be focusing on when you patch. So the lesson here is that our intelligent adversaries are sort of focusing in areas that we might not be. And so that small percent may be where we should be focused. And it doesn't mean that we have to be patching in that area, but we definitely need to be thinking about it. So for example, in PCI as a requirement, as you move through compliance, you might be taking care of a lot of stuff. And if you're not required to take care of stuff attackers are attacking, it's sort of like you're saying, well, I'm not required to prevent this breach, so I'm not going to do anything about it. And that's a key problem we run into when we don't have good, strong regulations to force people to take action, and they don't feel a market incentive to do it. So the attackers are really targeting more data in more places, bigger lakes of data. They're finding these flaws faster, right? They're getting the 0 days more often. And we have less control over the devices that people are using. So as they find more flaws and there's more data exposed, it creates a sort of a problem for our patching environments. So this is really how threats are changing, I think. This is really what's going on with attackers. They're focusing on becoming very targeted, so they're actually out there looking for very specific things. They're finding ways to interact with people and with systems better, and they're becoming much more stealthy, so they're harder to find. In the target case, I'll keep using this because it's on people's mind, they said it was stealthy because it removed the file once it downloaded on a point-of-sale device and it uploaded to the command and control server, so that was defined as stealthy, I guess. But the fact that it created a file in the local system and no one noticed is not a high bar for stealthy. Right? It created a text file with all the credit cards in it. That should have been a red flag for any point-of-sale device. An FTP session should have been a red flag. FTP session alone, plain text FTP over the internet is not allowed by PCI. The fact that it went to Russia, you can say that should have been a flag too. So it really comes down to, are we focusing on the right things? And so I think we have to take a step back first and ask ourselves, this has actually gone down, I'm really happy with, in the the news lately. People have said sophisticated less. But in 2010, when I really started this campaign, I wanted people to stop saying attacks were sophisticated, because I felt like it was like I wanted to put sophisticated into everything else I saw. So a tornado knocked out a town in the Midwest, it was a sophisticated tornado. Or ice storm hits the East Coast, very sophisticated ice, prevented people from driving. And I think it's because, for me, sophistication represents a lack of understanding, which isn't a bad thing. It just means this is a complicated problem we don't understand. And a lot of these attacks that we're calling sophisticated are on the low end of the spectrum. They actually are not sophisticated. We're just focusing in the wrong areas. And so here's my example of how the industry can sort of bifurcate and continue progress without destroying itself. We tend to say, no more checklists, they're not working. Get rid of PCI, it's just a dumb checklist. And that's not good advice. So if you're flying, in this case there's a helicopter, right, and this guy is training someone to fly the helicopter, they follow a checklist. And if you get into an airplane and fly anywhere after this conference, you will be glad that someone's using a checklist before they take off on that runway. And this is for the simple stuff. But on the far end of the spectrum, in the unknown and the sophisticated space, there may be advanced attacks. So once those helicopters are in the air and they're actually trying to figure out who they should shoot with missiles, for example, because they're a threat, that's a different, there's not a checklist necessarily. There's sort of an assessment piece there, there's an analysis piece. So this is how we're dividing up, I think, the world. And it shouldn't be like an 80-20 rule. It should definitely be some spectrum of fit for different industries. But one of my favorite checklist items is PCI DSS requirement 2.1, which is always change vendor-supplied defaults before installing a system onto your network. And this, I think, gets overlooked a lot. But when we argue about how, I can't go into too much detail, but how weak defaults are and how defaults have exposed us to additional risk, there's a large debate now about how we should make defaults so secure that people don't have to think about systems when they install them. That is not realistic if you look across the spectrum of safety. We do not run our helicopters in default mode. We do not run our cars in default mode. They're easy, but they're not so easy that we take away all decisions. Networking might be a good example. When you get your computer in default network mode, you configure it. Right? It's not going to work without you doing some configuration. So I think you have to think about defaults as something that has to be changed, and that needs to be pushed out in the industry as much to balance the idea that customers should have to do very little work. There also should be some change of defaults. Okay, so I'll hand it back to Alice, and then that's kind of my rundown of how attacks have changed and how we should change our focus into defending ourselves before I get into the actual defense modes. Allison, back to you. Lost sound. Microphone?
Oh, sorry, I muted myself. Only 10, that'll happen. So is this the magnifying glass slide?
No, this is the whale breaching.
Oh, good. Okay. So Davi set aside some time for me to talk about whale breaches. And I have a lot of opinions about some of the recent breaches, but rather than turn this into a rant session, unless folks have questions for me, I just want to focus on two aspects of the recent data breaches that I think are most interesting. So the first is that what I have found sort of fascinating is less about the exposure and the compromise and more what some of the compromises are telling us from a payment nerd standpoint. So I've been in information security and risk, but I've also been pretty deep into the payments industry. And so while normally one thinks of something like a point of sale system as being simply an endpoint at which payment credentials are obtained, what the recent compromises are telling us is that some more sophisticated whale-level entities are actually integrating in potentially other systems associated with payment, but not directly related to payment, such as reward systems, and also managing the financial products that they themselves issue. So you'll see some of this maybe hinted at in some of the discussion that's happening in articles. The reason why some of these, some data that's not specifically card mag stripe data that may have been somewhere swimming around at the point of sale, despite the fact that that wasn't something that the customer with the card was actually handing them. Anyway, there's a lot, what's happening here is there's some integration decisions that fairly sophisticated folks are making in order to provide added services potentially, or reduce their own costs associated with what is happening with their payment processing. That's interesting to me from a payment nerd perspective, but actually not specifically relevant to how the breach was conducted. So that's just something that I've been grokking out on. But the other aspect of the recent breaches that I find very, very interesting is how they surface. So when we hear breach, I think we always think of the primary definition of breaching, which is basically for something to be violated, bust out, or something is tearing through. But the other definition of breaching when it comes to whales is sort of apropos. It's when the whale actually surfaces, when it comes up out of the water. So the thing that I think that we might want to take away from some of these compromises that are coming to light is how they are coming to light, not just the fact that they are occurring. I mean, malware in a client system on an endpoint somewhere, okay, and how it got there, very interesting. But how was the compromise found? Was it found through a compliance program? No. Was it found through a more rigorous audit? No. Was it found through some sort of signal that showed up in a monitoring system at the victim location? No. The way that these breaches are being found now is other data whales hearing the siren call of the whales that were breached, essentially, seeing clues in their big data that tell them there is a problem with that whale over there. That is how these compromises are being found. So in the credit card world, there's actually a specific term for this called CPP, or common point of purchase, and it requires a lot of sophistication to understand, hey, I'm seeing some weird transactions, and what do all of these weird transactions have in common? What do these customers have in common? Oh, look, they all shopped at the same place. That requires a certain scale of data and a certain approach to understanding the behavior of cardholders, and I think it's actually impressive that we're actually seeing a reduction in the time to live of these compromised situations because they are breaching faster, they're coming to light faster, and it's the folks downstream who normally suffer the burden of this that are finding it, right? Because when card data is compromised, it doesn't necessarily get used at the victim from whom it was compromised from. It gets used at third-party downstream locations. And so these are these downstream locations using their own big data to sort of to find things out earlier and protect themselves. So that's my little bit on breaches. Anyone have any questions for me on that before we move off to that? Nope, I don't see anything on Skype or on Twitter, so let's keep going and start talking about other modes of defense.
All right.
How defense has evolved.
Anybody keeping track of how many puns we've used so far in this presentation? There will be a quiz at the end. Closest guess wins something. All right, so now on to defense modes, my favorite part. So I think, let me emphasize again, what's happening is we're actually getting successful in some areas, and other areas are still open and fertile ground for the attackers. So what do we do to close the gaps further? This to me is a continuation of success we've had in the past into new areas. I think people are very like doomsday-ish about like, oh my God, we've been failing for so long, we're not going to be successful ever. And all right, back to the noise versus signal analogy. No, we're actually being quite successful in some areas, and so I think we need to learn from that and move ahead and not get in too much despair about how we have failed. So I'm going to talk about 3 different modes as a progression and how we're going to get to data-driven from whack-a-mole. So the first interesting thing I've noticed is how many people are familiar with the Deming cycle? Have you heard of the Deming cycle? Auditors are familiar with this generally. It's the Plan, Do, Check, Act. It came out pretty famous in '48, and it's been used. How many people know that Deming was in the Army? He was a statistician doing statistics for the U.S. Army during World War II, right? So that, to me, is one of the key issues here. He learned from the U.S. Army during World War II, if you're familiar with the Sherman tank as an example, how bad it was at the beginning of the war and then how they used it more effectively over time. And by the end of the war, he had a boatload of knowledge about how to build quality into systems. And where did he go with that knowledge? Japan. And what did he do with it? He built the Japanese car industry. They were very receptive to US influence at that point. And so he told them, you know, this is how you will make a better industry. For recovery of the country, your industries will run like this. And suddenly Japanese cars had so much quality versus the US, who pretty much ignored our own information. The US Army couldn't tell the US companies how to improve quality in their cars. They had to compete with Japan. But that's not really the point. The point here is that in 1950, we had these 14 lessons from him. We had the Plan, Do, Check, Act. You know, he was working early in how to learn and patch better. And it's been around for a long time. But by 1996, we still hadn't learned these lessons that we should have known so well. And if you look at history going back even further, it was there, of course, if you look at military history especially. But in 1996, I have personal experience with this, but I was working with a team, and they launched a satellite with a ton of scientific information in it, and it was blown up. They remote destructed it because it had an overflow exception that was very, very basic. Super simple mistake. The analysis of the mistake ultimately was that a software exception caused the entire thing to fail. And most importantly was that the software exception was in a system that wasn't critical. So this non-important piece of the rocket that was still running after it had launched, that really should have been shut off, instead had a critical exception because a critical exception anywhere meant the whole thing should be shut down, the whole rocket went awry, and they had to destroy it. And then they had redundant systems built in, but because they had the same operating system running, essentially, that when it failed on one, it had a floating point exception error, essentially doing an integer conversion. But when it failed on one side, it switched over to the secondary, which ran the exact same thing, and then it failed again. So basically what they decided was software should just be assumed to be faulty. Now the reason I point this out is because it was a big deal in 1996, and there were studies that you should always assume software to be faulty. And in 2010, I'm reading these people saying, you know what we discovered? Software should be designed to be faulty. So Netflix, for example, we got on AWS and we realized that we should design software so that you can expect and tolerate failure. And I keep thinking, like, we learn these mistakes over and over again. And what's really happening is that we're doing this sort of whack-a-mole, and people are learning it and doing it, but not really getting that much further down the line. It's good, like I said, patching helps to a degree, but we're not getting super far. And this is my favorite one so far, where in 2012 people started saying, I think the source of this is actually in Europe. I found someone who said it first, perhaps at CERN, but cows aren't pets, so when a service fails now, you should kill it like you kill a cow, because we shouldn't treat servers as our pets anymore with names. And so I took this to the extreme, and I decided the IoT, the Internet of Things, is really the Internet of tofu. We're moving further along the evolution of progress here. But I kind of disagree with this in some sense, because the people saying it are, like, for example, Netflix was saying it quite a bit. They're a service too. So if you take this attitude that we should just kill things with no regard for breach causes or failure causes, then you would just disregard Netflix. As soon as it failed, you'd be like, oh, I'm done with that service. I'm going to switch over to something else, you know, Hulu. So we really do actually have to not just kill things, but really look into them a bit like they're pets, really understand them and take them to heart. And that's where we sort of move into the second part of this. But before I get to the second mode of defense, I also want to point out that it's been 50 years this year since patching was really started, right? So the IBM System 360 was a revolution for its time, because you could actually upgrade the software on it without rewriting everything for the specific hardware. And so after 50 years, you know, we're still focusing on this sort of cow analogy of just shoot stuff and kill it and move on. And so I think there's something to be said for patching and using that. There's definitely information there which is very useful in terms of defense, but it's not solving our problem. And one of the reasons is because of resources. And so that's where threat modeling came about. So how do we focus on where the threats are actually attacking? And so that was sort of been the focus for the past so many years. I'll hand this back to Allison for a second to talk about the SIM market, but I will just say what we're seeing is an evolution here from IDS, which is essentially an outbreak of patching. So if you didn't patch the system, you can at least look for the attack on that particular patch with IDS if you know the exact signature of a very signal, well-defined event. But if you don't know that, you can move into more sort of threat analysis using closely related events, and that's the SIM. So I'll hand it to Allison now.
Well, I'm not sure that I can speak too much to the evolution of the SIM market, but I will say that the sort of the tools that we are using are definitely evolving from more sort of signature-based configured like a firewall with rule sets with high false positives and such, to being a little more flexible and allowing us to create data-driven, and even incorporate some elements of learning systems in, so that it's things that look funny, not just things that we have decided in advance are going to be monitored on. So what this chart describes essentially is that evolution where we're going from bad use cases that are known in advance, coded by us, and added in to tools that can actually handle looking across events to correlate those events against each other and understand that there are similarities that might be of interest to folks doing the monitoring. And then finally, the incorporating in additional machine learning techniques or advanced analytics that identify potentially new patterns.
All right, so we're getting close now on time, so I'm really going to move on this next section. But it's probably just as well because it's a silly analogy, and it's a bit of a rant, so I'll keep it short. If you look at the history of the stoplight, it really drives me crazy. So anybody here a sailor or get on boats a lot, right? So port and starboard are fairly straightforward, and they're a really primitive threat management model, which is if you're on port, you lose, and if you're on starboard, you win. And this has sort of evolved into the green and red lights on the street, and it doesn't scale terribly well because it's really stupid, right? It just tells you to stop for no reason. And XKCD has a really good cartoon about this where, you know, somebody thinks really hard about how to design intersections, and then you as a driver pull up to the light and you go, I'm smarter than this light. There's nobody here. Why am I sitting here? Why can't I drive through? And so you get into this argument with the person who designed the infrastructure of controls, which is the same thing as being in a big data environment and saying, get rid of your controls, performance is the key here, I know how to go fast and where and when. And then the IT department is like, no, stop, we need to make this environment safe. So it's really a good analogy because if you've seen lately, Audi released a car that actually intelligently tries to figure out what the lights are going to do and then slows the car down to make sure that you don't have to hit the brakes. And so you can continuously drive at a speed through all the greens. And this is sort of a semi-intelligence, which I do myself. Like I know certain streets in San Francisco are timed, so I can just drive all the way across the city in 15 minutes by hitting all the green lights. And designers are trying to figure out ways to create these secret highways. But the ultimate answer, and there's a company already building this, is the lights themselves become peers where they actually sort of communicate with each other about traffic, and they create green lights for you. So if you're driving, you just always hit green. You don't have to do any thinking. So this is actually an interesting proposition because not only is it more intelligent controls like you want in your environment where you have email, for example. It doesn't keep prompting you and you don't have to go through all the authentication. It just knows you're safe for some reason. It knows how to navigate you through but stop others who are threats. And so after putting in this system, a community apparently can save, for example, $8 million a year or 33 years of time in terms of people wasting time at lights. It's pretty amazing, or the amount of fuel that they save. So with that analogy, let me move into another analogy, which is, you know, aviation safety. People have talked about this a lot, the NTSB and so forth, and I don't look at the success as much as I look at the failures. And what I found was in Africa, there were a ton of crashes, and people had studied this and found the leading cause of crashes are not the technology. You can outfit these planes with a ton of really sophisticated controls and technology, but they can't overcome the fact that the infrastructure is crumbling, there's bad authority, and they don't have really good regulation. And so in InfoSec, that would be like taking responsibility, having a regulatory body take over, like the PCI SSC, and then having enforcement do something about it. And I'm really a big fan of these, but I don't think we're solving them fast enough. And I can give an entire presentation about that. So instead, what we're focusing on now, even though I think these three are probably the chance of our success is dependent on them, we're focusing on the fourth, which is that we are building environments where people are struggling to actually put controls in place. So the patching isn't working. We need a better solution. And so the answer has come to what we'll call here is the data-driven third wave. And with 5 minutes, let me move through this quickly, but I think Stephen Wright summed it up nicely, which is, if I can't fix your brakes, I'm just going to make your horns louder. And so you'll actually know when threats are coming. And so we're moving to a trust model using dynamic information, using basically the same big data model being used for business, we're using for security. And we're using feedback loops. So you have a ton of information about whether somebody is friend or foe based on all of their activity and past. You're really looking at them as a much more rich data source. The password is very primitive, but an entire information source about somebody's history is very useful in identifying them. And so here's an example from Allison of how you're doing this with fraud. You can see the stoplights are still there. You can decide to stop somebody or let them go based on the information that's coming into the system. And so we're using essentially a scoring model or an analysis model And so there's a bunch of examples in here I'm going to have to skip through, but one of them is that if you look at all of the output in wastewater in Chicago, they were looking for diseases, environmental risks, for example, but they also figured out they could tell who was buying prescription drugs illegally, because in the wastewater it showed prescription drugs, and they looked at who was buying them, and they put the two together and said, well, they didn't buy them from a source that we authorized, but they actually took them because it's in their toilet water. So you can get some pretty interesting examples here. Espionage, of course, everyone's familiar with, the NSA tracking all of our behavior using some basic metadata. What we're trying to do really is move to levels of deciding whether someone's a friend or foe above the nominal and into something more like interval, which is heat. So you can build heat maps that tell you whether someone is actually safe in your network or not, and it gives you a meaningful difference between the good and the bad. It would be great to even move to a ratio, which is this person has a $50 potential threat to your environment, whereas this person has a 5% or $5 threat to your environment, so you can act based on how much money you have in response. And here's a quick example of what it sort of looks like. You have these different entities, and you can just differentiate and bifurcate them by different models of analysis, whether there's a relationship between them or whether there's a separation between them. So that's sort of advanced measurement theory, which leads into prediction of where the next attacks will be coming using the analysis. And so where we're really headed is, in the past we were doing upgrades on terminals, we moved to personal computers where we started to patch, and now we're actually moving into a replace cycle, the cows, for example, into tofu, where we can intelligently just swap things out. This is the antidote to the Internet of Things fear that people are peddling right now, which is we can't patch them fast enough. We're actually going to start replacing devices, and that's going to be the future. Your phone gets replaced every 2 years, for example. It may accelerate, so pieces of your phone will be replaced. And so I think that's how, and you'll do it intelligently, so you'll replace things that are most attacked or most likely to be at risk. And that gets us to a peer model. This was designed in 1853, by the way, in response to a cholera attack. But this is basically applying the cholera safety model. And in an example that I pulled from work, we had 50 million events a month that we looked at in an environment. We reviewed only 1 of 2,000 events, and we still caught 92% of the fraud. So if you go to the airport, they stop 1 of every 1 person. We're stopping 1 of every 2,000 people that are going through the environment, and we're still catching over 90%. And 90% was the watermark they gave us. You catch above 90%, that's success. We could go higher, but there's a cost. And so the defense evolution is moving from the centrally planned light system where you're trying to stop all the cars and figure out traffic to where they actually sort of figure out themselves who should go and who should stop. And that's like in the boat model, but it's applied to where when you're driving a boat, you really are intelligently deciding whether you're going to hit somebody else and moving around them. You're never really stopping and waiting at empty water and saying, eventually a ship will go by, but I'm just going to sit here for a while until it's safe to go. All right, so with that, here's a quick illustration of what it looks like. You probably can't see anything in this. It's a bunch of little like egg floating around like fish eggs, and then if you use some analysis, it turns into this, where with the color you can see there's 3 attackers within the colored eggs stand out. And so it's essentially something effectively where you're saying, here's an adversary among our customers. So in the target case, you could look at behavior that was unusual for your environment. You could see that someone was FTPing out of your environment. You could see that there was a text file being created on the desktop that hadn't been there before, with a name that wasn't recognized. You can even see if people are behaving in ways that is unusual for them to detect heart attacks, to detect health risks, and so forth. So with all of that being said, it's great for security, but it's also a huge risk, because in 1968 there was a lot of discussion of this, and I encourage people to go back and look at it so we don't repeat ourselves. But essentially in 1968 a lot of people were saying, hey, if you start doing all of this analysis of all of this data, it really ends up with people killing each other. And so HAL might be the best example of the computer that killed all the crew members in order to save them. And so this is another example of World Memory, a book by an Italian author who said that if you auto-transcribe everything, it really just leads to us wanting to kill each other. So with that, hopefully we've illustrated some of the challenges and some of the solutions, and I will thank you for your time.
So we're right up against our limit, so we might have to take questions offline, because the next speaker has to come in and set up. So if that's okay, we can move. There is up the next floor.
Okay.